All right, this is the second video of two talking about function notation. So you'll notice over here at the left, we've got a little bit of function notation given to us. It says g of 2 equals negative 3 and g of negative 2 equals 5. What we want to do is find the slope, right, of the graph of a linear function g, our function g here. So it's not f of x this time. We're saying that g of x was a function, right? G of x was a function. We don't know what that function is, but we do know a couple of inputs and outputs, right? 2 being in the domain, negative 3 being its partner sort of in the range, right? Negative 2 in the domain, its partner in the range would have been 5. If you want to write those in a different form, technically we could say that we inputted 2 when the output was negative 3. Or for an input of negative 2, the output is 5, which makes it very simple. If I want to find the slope, remember y2 minus y1 over x2 minus x1, all I have to do is insert my points then. So 5 minus the negative 3 becomes plus 3. And because I used the 5 first, I'm going to say negative 2 minus, again, my x value from the first point, right? Negative 3 was from the first point, 2 is from the first point. So 5 plus 3 would have been 8 divided by negative 4, right? Negative 2 minus another 2, going down another 2, and 8 divided by negative 4 is negative 2. I would say the slope of the line between those 2 points, right, between g of 2 equal to negative 3 and g of negative 2 equal to 5 is negative 2. Now, that's just one way algebraically we can use the idea of function notation, right? It's just a different way of reading the points. G of 2 is saying input 2, output negative 3, right? Well, another way we can do that is using real world problems. What if they give us a function, right? F of x equals 4,250x plus 330. It represents, again, the number of DVD players sold in thousands. Now, we're going to want to keep that in mind, in thousands in the US between 1998 and 2003. Notice, though, at the end of the problem, they also point something very important out. X is the number of years since, right, 1998. So I'm not going to be inputting the actual year. I want to input the number of years since 1998. So when they say find the number of DVD players in 1998, well, 1998 is exactly 0 years after 1998, right? It's actually year 0. That's the beginning. So what they're really saying is find f of 0. Let's take our function, 4250 times x, which for us right now is 0, plus 330. Well, 4250 times 0 plus 330 is just 330. Right, so f of 0 equals 330, which would mean, again, because we're measuring in thousands, that in 1998, right, there were 330,000 DVD players sold, right? 330,000 DVD players. So that'd be another way of writing that answer. Again, if we want to find in 2003, we need to figure out, well, hey, wait a minute, that's 5 years, right? 2003 minus 1998. I would say that's when x equals 5. So let's find f of 5. So 4250 times 5 this time plus 330. Well, that would be 21,250 plus 330, or basically f of 5, right, in 2003, there would be 21580, right, add 330 on there, 1,000, right, DVD players, so about 21 million, right, 1,000 is a million, 21,530,000, 21,530,000. Again, DVD players sold. Okay, so don't forget to write that with the label on there. Graph the function and identify the domain and range. Well, now these are kind of crazy numbers. So what I'm going to do is kind of think about this and say, wait a minute, I can't really go past into negative numbers. We're starting in 1998, which again was year 0 for us. So I'm going to start in year 0. We're only going to 2003, which is technically year 5. We started at 330,000 DVD players, according to that blue coordinate we found on the left. And we're not really going past, right, in year 5, 21,530, right, in thousands. So again, I'm going to very simply make a simple sketch that basically says 0, 330 and 5, 21, 530. Those are the 2 points that I need. And in fact, that'll even help us with the domain and range. Our domain is only those first 5 years. So all of my x values are going to fall between 0 and 5, including 0 and 5. As far as the range goes, well, for that span of years, the lowest number we had was 330. And all of my y values were greater than or equal to, right? 330 was less than or equal to y. That's the lowest that y went. And y was also less than or equal to 21,530. That's the highest that y went, right? Again, your range is just that sort of span top to bottom. Your domain, that span left to right, that we're looking at on the graph. And then finally, well, what if they asked us for the value of x? Well, I'm finding x. That means they gave me the f of x value, 13,080 here, equals 4250x plus 330. So the first thing I'm going to do is subtract 330. I want to try to solve this equation. So that's 12,750, I believe, still equal to 4250x. But again, those 330s canceled away. And then if we divide by 4250, right, we're multiplying on top, so let's divide. Let's get rid of that 4250. Then x equals, and I believe that comes out to 3. So what that tells us is, in 3 years after 1998, so in 2001, we sold, right, 13080,000, right, DVD players. Just that simple. 13,080,000. Again, you can just write that with zeros on it or just write the word thousand. Don't forget that's part of the label, DVD players. I hope that helps you apply function notation, both in the real world, in that situation we just talked about, also talking about domain and range a little bit, as well as just in sort of function notation. If we're talking about slope or just talking about functions, we're talking about graphing things. Again, function notation is just another way of writing inputs and outputs. If you have any questions, talk to your teacher, and have a great day.